Elon Musk just threatened to shut down Dragon. NASA's only ride to space, gone. But here's what nobody saw coming. While everyone panicked, NASA discovered DreamChaser isn't just a backup. It's actually better than Dragon. This spaceplane lands on regular runways like a jet. No ocean splashdown, no recovery ships. Just roll up to any airport and unload. Dragon wastes 40% of its space every flight. DreamChaser uses it all. Medical emergency in orbit? DreamChaser lands immediately anywhere on Earth. The discovery that changes everything? NASA just realized they don't need SpaceX anymore. Let's dive right in. DreamChaser main body, YouTube script. The room went silent. December 15th, 2024, NASA headquarters, the call from SpaceX had just ended. Elon Musk's ultimatum was crystal clear. Cut our contracts, we cut Dragon. For the first time in 4 years, America faced losing its only path to space. But what happened next? Nobody saw coming. The moment everything changed. 3 hours after Musk's threat, NASA's emergency team was already running scenarios. Dragon gone, Soyuz as the only option, 3 astronauts maximum on the ISS instead of 7. Research programs, dead. The International Space Station, slowly dying. Then someone in the back raised their hand. What about DreamChaser? The room erupted. DreamChaser? That experimental space plane collecting dust in Colorado? But as the data came in, minds started changing, fast. The hidden numbers that shocked NASA. Here's what NASA discovered that night. The numbers that changed everything. Dragon's big claim? 6 tons of cargo capacity. The reality? It never carries more than 3.6 tons. Why? The capsule's cramped interior, bulky equipment simply doesn't fit. But DreamChaser's cargo bay, spacious, flexible, built for the equipment Dragon leaves behind. Then came the efficiency bombshell. Dragon costs $55 million per mission, but delivers partial loads. DreamChaser could deliver more cargo for less money. NASA's accountants ran the numbers 3 times. Same result. They'd been overpaying SpaceX, the life or death scenario. But the real awakening came from NASA's medical team. Dr. Sarah Chen, chief flight surgeon, painted a terrifying picture. Astronaut has a heart attack on the ISS. Dragon takes 19 hours to return. Then ocean recovery, helicopter transfer. By the time we get him to a hospital, she didn't finish the sentence. She didn't need to. DreamChaser changes that equation completely. 12 hours to any major airport, ambulance waiting on the runway, no delays, no transfers, no unnecessary deaths. The room went quiet again. This wasn't just about backup plans anymore. This was about saving lives. The engineering marvel nobody noticed. While everyone obsessed over SpaceX's reusable rockets, Sierra Space had quietly solved the hardest problem in spaceflight, landing precisely. Dragon aims for an ocean area bigger than Texas. Missed by 50 miles? No problem. It's all water. DreamChaser has to hit a runway 150 feet wide. The precision required? Like throwing a dart from New York and hitting a bullseye in Los Angeles. Yet DreamChaser's autonomous system does it perfectly, every time. How is that even possible? The heat shield revolution. But could DreamChaser survive re-entry? The brutal 1,650-degree heat that melts steel? SpaceX spent a decade perfecting Dragon's heat shield. Sierra Space had to start from scratch. Their solution? Pure genius. Instead of copying SpaceX, they went back to the shuttle's proven tile system, but with a revolutionary twist. 2,000 custom tiles, each one precisely shaped. White tiles reflect solar heat in orbit. Black tiles radiate heat during re-entry. Perfect thermal management. The result? A heat shield that's lighter, stronger, and more reliable than Dragon's. The $20 billion hostage situation. December 2024 exposed America's terrifying reality. $20 billion in SpaceX contracts, Artemis moon missions, ISS operations, all controlled by one man's ego. When Musk threatened to pull Dragon, NASA had 0 alternatives ready. Boeing's Starliner failed its test flight, Blue Origin, no crew vehicle. Russia's Soyuz, 3 seats maximum. For the first time since 1961, America couldn't put its own astronauts in space without begging someone else for permission. That's when NASA realized DreamChaser wasn't just a backup, it was independent. The capacity lie everyone believed. SpaceX's marketing machine claimed Dragon carries 7 astronauts. The truth? It typically carries 4. Those extra 3 seats, they exist on paper, but weight limits make them unusable with full supplies. Pure marketing fiction. DreamChaser's crew version targets 5 astronauts, but here's the difference. It can actually carry 5. With full life support, with full supplies, no fictional capacity. The ISS normally runs with 7 crew members. Losing Dragon cuts that to 3 using only Soyuz. Research productivity collapses overnight. DreamChaser maintains 6 crew members, close enough to keep operations running, close enough to keep America's space program alive. The $86 million ransom. Remember those dark years after the shuttle retired? NASA paid Russia $86 million per astronaut seat. It felt like paying ransom. Dragon brought prices down to $55 million. But it came with Musk's unpredictability. One Twitter tantrum could strand American astronauts. DreamChaser represents something different. American capability without billionaire drama. A spacecraft that answers to NASA, not shareholder whims. What's independence worth? Apparently, everything. The runway revolution. Every spacecraft before DreamChaser lands in one place. Ocean splash zones, predetermined sites, no flexibility, no options. DreamChaser can land at any major airport worldwide. Mission emergency? Land immediately at the nearest runway. No waiting for perfect weather, no waiting for permission. This changes everything. International missions could end at destination countries' airports. No more shipping cargo halfway around the world. No more dependency on single landing sites. The contamination problem Dragon can't solve. Here's what SpaceX doesn't advertise. Dragon's ocean landing destroys sensitive cargo. Saltwater exposure, violent impact. Delicate electronics, ruined. Biological samples, contaminated. Years of research, lost forever. NASA's been losing millions in experiments to Dragon's brutal landing system. They just accepted it as the cost of doing business. DreamChaser's gentle runway touchdown preserves everything. Experiments keep running during descent, data stays intact, nothing gets destroyed. For NASA's science missions, this isn't just an improvement, it's a revolution. The manufacturing vulnerability. SpaceX builds Dragon at one facility, Hawthorne, California, single location, single point of failure. What happens if that facility goes down? Natural disaster? Cyber attack? Labor strike? Dragon production stops, period. DreamChaser's production spreads across multiple states. Wings in Colorado, heat shield tiles in California, avionics in Maryland. Distributed manufacturing means distributed risk. This geographic spread creates another benefit. More states invested in the program. More senators supporting funding. More political protection. The International Independence Card. Dragon launches exclusively on Falcon 9 rockets. That means every international partner needs SpaceX's permission. Want to fly with Europe? SpaceX decides. Want to work with Japan? SpaceX gets veto power. DreamChaser launches on multiple rocket systems. ULA's Vulcan Centaur today. Blue Origin's New Glenn tomorrow. Even international rockets could work. Partners get choices. NASA gets leverage. America gets independence. The data revolution nobody's talking about. While Dragon focuses on hauling people up and down, DreamChaser carries something more valuable. Information. Advanced sensors, high-resolution cameras, real-time Earth monitoring, continuous data streams that Dragon's limited systems can't match. Climate research, disaster response, agricultural monitoring. DreamChaser could revolutionize how we study our planet from space. The question isn't what DreamChaser can do, it's what we've been missing without it. The hidden cost reality. SpaceX advertises Dragon at $55 million per seat, but that's just the launch price. Add recovery ships cruising the Pacific, helicopter operations, hazmat teams for toxic fuel cleanup, months of refurbishment. The real cost approaches $100 million per seat. DreamChaser's runway operations? A tow truck and a hangar. No ships, no helicopters, no toxic cleanup. Fraction of the operational costs. The economics aren't even close. NASA's been getting robbed. The emergency that changes everything. Picture this. It's 2026. A solar storm damages the ISS. Astronauts have hours to evacuate before radiation levels turn deadly. Dragon, 19 hours minimum to reach the ground. Then ocean recovery. Then helicopter transfer. The astronauts could die waiting. DreamChaser? Land at the nearest airport in 12 hours. Medical team waiting on the runway. Lives saved by landing on concrete instead of water. This scenario keeps NASA physicians awake at night. DreamChaser finally gives them peace of mind. The precision that seemed impossible. Landing on a runway requires accuracy measured in feet. Not miles, not city blocks, feet. Dragon splashes down in an area the size of Connecticut. DreamChaser must hit a target smaller than a football field, while traveling at 200 miles per hour. The autonomous guidance system that makes this possible, it's more advanced than anything NASA used on the space shuttle, more precise than human pilots could ever achieve. The timeline that terrifies. NASA DreamChaser's first cargo flight? Late 2025 at earliest. The crew version? Late 2020s if everything goes perfectly. That's years of vulnerability. Years where Musk could make good on his threat. Years where America depends on the mood swings of one man. NASA quietly started fast-tracking DreamChaser development. Extra funding, priority testing, expedited certification. The space agency that moves like a glacier suddenly found urgency. The discovery that changed everything. Back to that December night at NASA headquarters. As teams ran through DreamChaser's capabilities, one engineer made the connection that changed everything. We're not looking at a backup to Dragon. We're looking at Dragon's replacement. Better cargo capacity, better landing precision, better safety margins, better operational costs, better everything. The question stopped being whether DreamChaser could replace Dragon. The question became, why wouldn't it? The political earthquake. When news leaked that NASA was fast-tracking DreamChaser, Washington went into overdrive. Senators from SpaceX states panicked. Senators from DreamChaser states celebrated. Defense contractors started calculating contract values. The space industrial complex was about to get reshuffled. But behind closed doors, even SpaceX supporters admitted the truth. America needed alternatives. Musk had proved that dependency was dangerous. The secret meetings. What NASA hasn't announced publicly, they've been meeting with Sierra Space weekly since December. Acceleration schedules, funding increases, certification shortcuts, everything needed to get DreamChaser operational before Dragon becomes unreliable. These aren't backup plans anymore. These are replacement plans. The moment of truth. As 2025 unfolds, the space industry watches nervously. Will Musk follow through on his threats? Will DreamChaser meet its timeline? Will America maintain its independence in space? But NASA's December discovery changed the game. They didn't just find a backup to Dragon, they found something better. The era of depending on one company, one man, one spacecraft is ending. DreamChaser isn't just NASA's insurance policy, it's their declaration of independence. And judging by the billions now flowing toward Colorado, they're betting everything on it. Space Corps video. Outro. So here we are. December 2024 changed everything. NASA discovered they weren't just getting a Dragon backup, they were getting Dragon's replacement. Better cargo capacity, runway precision, emergency response, lower costs. DreamChaser didn't just match Dragon, it crushed it. But here's what really matters. America's space independence. No more billionaire hostage situations, no more $86 million ransom payments, just reliable, American-built spacecraft answering to NASA, not Twitter tantrums. The question isn't whether DreamChaser will succeed. The question is, what happens to SpaceX when NASA doesn't need them anymore? Because while Musk was busy threatening NASA, Sierra Space was busy making him irrelevant. What do you think? Is DreamChaser really the Dragon killer? Or is this just another case of NASA overpromising? Drop your thoughts below. And if you're fascinated by the hidden battles shaping our space future, you're going to love what we've got coming next. The Artemis program has secrets that would blow your mind. Hit that subscribe button, because the space race just got a whole lot more interesting. Space Corps, where the real story lives. $22 billion in SpaceX contracts just got threatened by Trump. And Elon's response? He's threatening to kill Dragon. But here's what nobody's talking about. Starship keeps exploding because of one simple problem. It's underpowered. The rocket is 20 times heavier than Falcon 9, but uses the same 6 engines. Flight 7, flash ignition. Flight 8, engine failure. Flight 9, fuel leaks everywhere. SpaceX is literally pushing these engines to breaking point just to reach orbit. The Raptor 3 engine is their last hope. 280 tons of thrust, lighter design, and they're betting everything on it. But will it work? Let's dive right in. The truth behind those explosions? It's worse than anyone imagined. Flight 9 was supposed to be SpaceX's victory moment. Payload bay opens, satellites deploy, mission success. Instead, the doors stayed shut, locked tight. Those dummy satellites became expensive prisoners in their own metal cage. But this wasn't just a door malfunction. This was the moment SpaceX's biggest lie finally caught up with them. The impossible physics problem. Opening a door sounds simple, right? Walk to your front door right now. Turn the handle, easy. Now do that same thing. While spinning out of control. In the vacuum of space, with zero gravity, and doors that weigh several tons each, suddenly not so simple. Most spacecraft have internal pressure helping them. The air inside pushes against the door, creating a tight seal. But Starship's payload bay, completely unpressurized, no help from physics. Just raw mechanical force fighting against the most hostile environment in the universe. And when things started going wrong, they went wrong fast. The nightmare begins. Here's what SpaceX didn't want you to see from Flight 9. The moment those engines shut down, the ship started tumbling, spinning wildly through space like a broken toy. Why? Fuel leaks. Starship's attitude control system works like this. Pressurized gas sits above the liquid fuel in the tanks. That gas powers tiny thrusters that keep the ship stable. But when the gas leaks out, those thrusters die. Picture driving down a mountain road, and your steering wheel just falls off. That's Starship in space. The spinning created forces nobody planned for. The door mechanism, designed for calm conditions, suddenly faced rotational stress it was never built to handle. Leaked fluids contaminated the payload bay. Every system began failing at once. But why is this happening to every single flight? The answer will shock you. The $20 billion lie. Every rocket engineer knows the golden rule of spaceflight. Thrust-to-weight ratio determines everything. If your rocket weighs twice as much, you need twice the thrust. Basic physics. Starship's upper stage weighs 20 times more than Falcon 9's upper stage, so logically, it needs 20 times the thrust to perform the same way. Here's the problem. 6 Raptor engines on Starship produce only 18 times the thrust of Falcon 9's single engine. The math doesn't work. Starship is fundamentally underpowered for its massive weight. This forces SpaceX into a deadly game. Push engines beyond safe limits. Cut weight everywhere possible. Hope nothing breaks. It's like trying to power a freight train with a motorcycle engine. And the consequences? 3 consecutive failures. Flight 7, the warning shot. January 2025. Starship Flight 7 carried its first real payload, 20 tons of dummy satellites. Just 13% of Starship's promised capacity. That tiny payload triggered catastrophic failure. A flash ignition erupted near the Raptor vacuum engines. Uncontrolled fuel combustion in the attic section between the oxygen tank and heat shield. Sensors detected massive pressure spikes. The ship was literally ripping itself apart from the inside. SpaceX called it an anomaly, but engineers knew better. This was the first crack in their facade. Flight 8, The pattern emerges. SpaceX learned nothing. Flight 8 launched with reduced payload, 4 satellites instead of 10, hoping lighter weight would save them. It didn't. Hardware failure struck the center Raptor engine, either fuel leaks or catastrophic overheating, both symptoms of engines running far beyond their design limits. 2 flights, 2 failures. Same cause, underpowered engines pushed to breaking point. But SpaceX kept the pattern hidden until Flight 9 exposed everything. The Pez dispenser deception. SpaceX markets their satellite system as the Pez dispenser. Cute name for a fundamental design flaw. Traditional rockets use clamshell fairings, massive doors that swing wide open, multiple backup systems, manual overrides, redundancy everywhere. Starship uses a single sliding door on the side. One door, one mechanism, one point of failure. When that door jams, everything stops. No backup, no alternatives. Just expensive satellites trapped forever. And here's the cruel irony. The door doesn't even support the structure. Reinforcement plates around the opening carry all the loads. The door itself could be removed entirely, if only it would open. The Raptor 3 Hail Mary. Enter SpaceX's desperate solution, Raptor 3. 280 tons of thrust versus Raptor 2's 230 tons. A 21% power increase that could finally give Starship the muscle it desperately needs. But here's where it gets crazy. Raptor 3 delivers more power while weighing less. 1,525 kilograms compared to Raptor 2's 1,630 kilograms. How is this possible? The answer involves the most controversial decision in rocket history. The no heat shield gamble. Raptor 3 engines will operate without base heat shields. Let that sink in. These engines work in plasma hot enough to melt steel, and SpaceX is removing their protection. Every engineer's first reaction, that's insane. But Elon's explanation reveals twisted genius. Heat shields create enclosed spaces where leaked fuel accumulates. The result? Catastrophic explosions like we've seen repeatedly. Without heat shields, leaked fuel burns off immediately in the surrounding plasma. The engine becomes self-cleaning. No deadly accumulation, no explosions. It's counterintuitive engineering that could save the entire program, or destroy it completely. The stainless steel trap. Even Raptor 3 can't solve Starship's fundamental weight crisis. The decision to build everything from stainless steel seemed brilliant during testing. Durable, cheap, crash-resistant. But now that weight is killing performance. Carbon fiber would cut mass dramatically, but SpaceX committed to steel for manufacturing speed. They're trapped between production goals and physics always wins. The hot staging breakthrough. SpaceX found one elegant solution hiding in plain sight. By blocking specific vents in the hot staging ring, they created asymmetric thrust during booster separation. This simple modification helps the booster flip more efficiently, saves precious fuel, increases payload capacity. It's the kind of brilliant engineering that makes you wonder, why didn't anyone think of this decades ago? But this innovation has an expiration date. The current system uses expendable staging rings. SpaceX's long-term plan requires reusable components. More complexity, more failure points. Block 3, revolution or disaster. The next generation Starship promises to solve everything. New hot staging design, Raptor 3 engines throughout, improved structural efficiency. On paper, it's perfect. But space doesn't care about paper. The vacuum of space has destroyed every perfect design ever created. Will Block 3 finally deliver on Starship's promises, or will new problems emerge from these radical changes? The stakes couldn't be higher. The political time bomb. Which brings us back to that explosive Trump-Musk confrontation. When the sitting president threatens to cancel $22 billion in contracts, and you respond by threatening to strand astronauts on the International Space Station, you've crossed into dangerous territory. Dragon spacecraft represents America's only access to the ISS. Canceling it would be national suicide. But Elon's threat reveals how desperate SpaceX has become. The company that promised to revolutionize space travel is now holding NASA hostage to protect their failing rocket. The Mars mission mirage. Every Starship failure pushes Mars further away. The rocket designed to carry 100 tons to the Red Planet can barely manage 20 tons to low Earth orbit. Artemis moon missions depend on Starship's success. Deep space exploration hangs in the balance. America's space dominance teeters on the edge. 3 explosions revealed the truth SpaceX desperately wanted to hide. Their revolutionary rocket is fundamentally flawed, underpowered, overweight, unreliable. Raptor 3 represents their last hope. Revolutionary engine design, meeting impossible physics requirements. The question isn't whether SpaceX can build better engines. It's whether they can build them fast enough before the money runs out, before the government loses patience, before their competitors catch up. Because in space, there are no second chances.